Right, we'll start here in about 30 seconds. So. Okay, so if you guys want to follow along on your phones or laptops or whatever, slides.com/QH web full stack part 2. If you do the /live, then I'll be controlling what you see. If you drop the /live part of the URL, then you'll be able to follow along the slides at your own pace. And the reason we do it this way is because we have a lot of code examples that are embedded in the slides, and so you can follow through those code examples as we're going through things. So let's go ahead and get started. My name is Quinn Heiner. I've been with SCG for about 8 years almost, 8, 9 years, somewhere around there. And I am a full stack .NET developer. And lately, though, I've been more involved in the front end side of things, but we try to do full stack. So if you guys remember our previous meeting, so this is a 3-part series on web development, full stack web development, and the stack that we're using Angular 7, and then on the back end we're going to be doing C# with .NET Core 2.2. So for those of us who, I just wanted to take a few minutes to do a quick recap of what we talked about from part 1, so we can delve into some more Angular topics. And kind of give, for those of you who weren't able to be here or weren't able to listen to the recording or anything like that, we talked about the full stack skill set and how being a web developer in modern times it's very overwhelming because we talk about all the different skills for front end and back end and DevOps, and we went through a lot of these things that you need to know, and it really came down to breadth versus depth. You know, knowing when to specialize in certain areas, target areas, when to unlearn things and learn new things, and then building a foundation in multiple subject areas with your breadth. We don't want to become too specialized because if that becomes your identity, especially in the web development world, your skills get outdated pretty quickly. We talked about the different learning paths. And we did a demo of the SCG profile site, and we'll be doing more of that today. We won't be doing a full demo like we did last time, but we'll show parts of the site in order to demo some of the topics. We talked about a SPA, single-page application, and how that's different than some of your other traditional web forms and page-based scenarios, even .NET MVC. We no longer really, you can call them pages, but it's more just a collection of components, and you're just hiding and showing in the DOM. You're not doing a full refresh of the page when you access things. We talked about Angular and the project structure. Talked about kind of how the Angular versioning was kind of confusing because we started with Angular version 1, and it was called Angular at the time. We upgraded to 2 and up, and they retroactively renamed Angular 1X AngularJS. So it's a little confusing, but we're going to be doing Angular 7 here today. We talked about modules, and just basically how modules are a place where we register our components, directives, pipes, and sometimes services, although we talk a little bit about the nuances with registering services and how if you do it at the root level, you really don't need to register it. But the modules were basically a way to break up our app into logical pieces. So, and we usually go on to do it by feature modules. With the site, let's see if I can go to them. Actually, we are. Thought I had it on here. With the site, we had 4 main areas. We had profiles, where we're basically listing of the consultants in the company. We have different groups that they're associated with, usually by skill set, and these are also become our role-based permissions. We'll talk about a lot more about role-based authorization in our next part of the series when we talk about the server side of things. We talked about the different, there's a skills area where we say, okay, for different skills, we want to know which consultants have those skills, and we've talked about the different clients. that the consultant works for. So this STD profile site was pretty easy to divide into those feature modules because we have those 4 main areas. And so in our actual code, if you go over to the way we, let's see, I am not in the right view, am I? Here we go. Can everyone see this okay? So in the actual code here, we have the client app folder. And in here, so all of our custom code by folder design convention in Angular starts with this source/app. And everything in the app, we notice we have these 4 areas, client, group, profile, skill, and then we have 2 more. We have core, which are kind of our use once areas. We're going to talk about some more stuff that we put in core. And then we have shared, and that is obviously use many. So with the use many, we have like our form components and a lot of reusable components that we want to use throughout the site. Those would go into shared. But other than that, your folder structure at the root level usually corresponds one-to-one with your features of your application. So in terms of our modules, kind of the anatomy, we broke it down and we talked about the 4 main areas, our imports, where at the app level we import our different modules because each of those areas are one-to-one registered with a module in and of itself. And then we declare the components. All of our components have to be registered in this declarations array in the module. And then, of course, the bootstrap is the main app when it starts up. And you notice there's no services in here. There would be a providers array where we would register services. However, because now that we have this provided in root stuff that we do to our services, I'll show you an example here. This guy on line 6 here, this provided in root, this means Angular will automatically pick this up and at the root level will inject it so that this service will be available to the rest of the application. You don't need to register it in a module. It's already there, ready to go, ready to be injected in your constructor. We talked about routing and how when basically you can kind of think of routing as a group, as a one-to-one mapping to your URL. So if I do /groups, we're going to have a route that corresponds and says this route goes with this component. And it's kind of a one-to-one registration. Obviously, there's a hierarchy. You have child routes. So we talked a little bit about that. And just to briefly show you kind of the anatomy of a routing file and how that works in Angular. We have this concept of being able to lazy load routes as well, which means we won't load any of the scripts or anything like that associated with that module until you access the URL, so it's lazy loaded. But for our purposes, we basically just give it a path, /search, /whatever, and then a component that routes to. So it's pretty straightforward. Routing in Angular, the newer versions of Angular, is a lot more straightforward than it used to be. Let's see, where were we here? Whoops. We talked about components and how really components are just your building blocks of your application and that they're basically just a class at the end of the day. They have state and behavior, and eventually they'll be represented in the DOM. And we talked about the 2 major types of components. You have either a presentation component, which is kind of the smallest fundamental self-contained building block that you're eventually representing in the DOM. It's usually associated with something visual. And then we have the container components. Your container components contain those child components that are presentation components. So, and we talked about when we generate our components with the CLI, we get 4 files. We get a CSS file for the styling, an HTML for the template, and then our spec file, which is for unit testing, and then our actual component class itself. Now, the great thing about components is that we can reuse them. So if we go to a couple of different areas of the site, stuff will load here, maybe not. We have this kind of standard list of consultants, our list of profiles that we have. So when we go to a group, you're taking forever here. We have a list of profiles. When we go to skills, we have a list of profiles. So it sounds like this is a prime component for a prime candidate for a component that we want to share among the different screens, among the different routes. So if we go into the code here, we go to any one of those screens that we saw. For example, let's go to the group. So we have our group list component here. Let's kill these guys here. Oops. Group detail, sorry, I was in the wrong one. So if we're in our group detail component here, you see we have this component here, STD profiles cards, and we prefix our components because if you remember, HTML is not only backwards compatible, it is forward compatible. So what we have to do is we have to have a namespace that we can do to say if, for example, like audio or video tags, back in the early days of HTML, if you were to put that, it would just render as a div. But then as HTML5 came around, and those things, those turned into something that the browser actually implemented. So to avoid those conflicts of being forward compatible and forward thinking, we prefix all of our apps when we create them with some sort of application level prefix to avoid those conflicts. Now, what's nice about this, and we'll talk about this as our next topic actually, is with this profiles here, with these brackets, we're doing property binding. So this element is present in all those other components, but when we pass it the data that hydrates that or that populates that component, all of that comes from different sources. So it's almost like the parent is controlling the data source for the child component. And that's a really powerful feature that we have within Angular. So we have this concept of parent and child components, and when we want to communicate with them, when we want to go from the parent to the child, we use the input decorator, and when we want to go from child to parent, we use the output decorator. And this is a way to directly pass data back and forth between, like I was saying, with those container components and those presentation components. To be able to pass data back and forth, we use inputs and outputs. So like I was showing earlier, that profiles cards here you see on line 4, we pass the data. If you were to look inside this guy, whoops, profile cards component here, you'll notice here on line 12, we've declared that value as an input. So we're expecting that data to come from the parent. And if we want to go the other way, in other words, an event emitter, we go the other way with output. So if we want to go from child to parent, parent to child. And that's basically where we left off last time in our discussion. So let's go ahead and move to the topics that I wanted to cover today. So the first topic I want to cover is this concept of, so we have parent and child components and we communicate between them using those input and output decorators. But we have a lot of times when we have these indirect relationships, whether they're siblings or grandparents, grandchildren, whatever the relationship is, we also want a way to communicate between those components. So this is where we can kind of tie into this concept of observables and services and how they work together. So observables. If you've ever worked with kind of the promise objects. With promise objects, it's basically an asynchronous operation, and then when data comes back, you have a success function and you have an error function, and you're passing data. So this is kind of the way we were used to doing things, is we just have some API call or whatever that comes back that we send up with the data, and then we have a return object on success and error. So observables are kind of like that, and if you're doing your standard HTTP call or whatever, it kind of behaves similar to a promise object. The idea is it's one and done. But observables are much more powerful in that they offer a stream of data arriving in chunks over time. So you have basically events. It's kind of an event or a pub sub model where the observable says, okay, something happened, and then you have 0 or more components, or whatever you want to call them, subscribing to that observable and getting data as it comes in. What's nice about observables, unlike promise objects, you can do retries, you can do cancels, you can do replays, and one of my favorite things about observables is you have a rich set of operators that you can operate on these observables, and you can daisy chain these operators together, these functions together, in a very fluent way to achieve some pretty cool behavior. So, in short, observables are basically just a way of saying, hey, something happened, and then you have 1 or more subscribers reacting to that event. And unless, I could be wrong, but as of the most recent version I've been using, if you don't have a subscriber to that observable, I don't think anything will fire. Is that correct, Micah? Yeah. So you got to have at least 1 subscriber for the observable to even have any effect. So hold on to that concept for observables while we talk about services, and then we'll link the 2 concepts together. So services are, you can use these for a very generic purpose. So you have generic utility classes that do more functional operations, more heavy lifting things, you know, string parsing and extension method type stuff. But one thing that services can be used for is to manage state in an Angular application. So in other words, when you want something to survive a route, or you want 2 components that are not parent-child relationship, you want them to be able to talk to each other, they can both depend on a service to hold that state. And the reason for that is because services, and this is very important, by default are singletons. So that means a single instance of that service class it's one instance that's used across the entire application. So, and then when we say application, we're talking client side. This is just the user's browser, right? So, it is raining. So when we combine this with observables, we can basically have all these unrelated components talk to each other, and they don't know anything about each other. So in other words, the services in general should never know anything about the component. They don't directly reference the component, but the component always depends on the service. So let's see an example of how these work together. So when we're doing a service-to-component communication, so we have this concept of a subject, and think of the subject as kind of a special type of observable with additional features. We can have more information on the status of these observables, on state information, and we can also facilitate more two-way communication with the subject. But at the end of the day, just think of subjects kind of like a special kind of observable. So if you notice here in the code, we have a service called confirmation service. And let me illustrate to you on the website how this thing is working. So if I go to a profile, and I try to edit it, and I go to delete it, we get a confirmation saying, hey, are you sure you want to do that? Please confirm. Okay? And you've got the yes or no option. So all of this, there is a single component that is associated with this pop-up, and it's shared among the entire site. So how does, from going to this, if we go in the actual code for this, in the profile detail here, let's actually go to the class for the component. So in the component class, when they click that delete button, I think it's profile info. The wrong one here. Okay. So when they click the delete profile button, all we're doing, so we've injected our confirmation service here in the top, right here. And it's literally just your standard constructor injection. Back with AngularJS, you had this array mapping that you had to do, and a lot of that was because of minification and kind of the messy things that happened with that. Now we have a very nice API for doing our dependency injection, and it works really nicely for unit testing and other things. You can mock your dependencies. So we have and remember in TypeScript, when we declare a private variable, we automatically have an instance. We could do this.confirmation service, and we don't have to declare that anywhere. by virtue of it being private in the constructor, we know that we can use it. So all we do is we just do .confirm, and we have a string message of what we want to say, and then we have callback functions on if they say yes and if they say no. So if we go to the confirmation service here, all the service is doing is doing .next on that subject. So it's basically just think of it as an observable saying, hey, something happened. Okay? So the service itself is very simple. Now, if we go, so remember this confirm event is just a new subject, and you can say, we're going to strongly type what we're passing on that subject. We go back into the actual component that's using this, is this confirm dialog. Okay? So what you saw there, that HTML, that pop-up, here's the template for it. And if you look at the component itself, you'll notice it has an instance of this confirmation service. And all it's doing is when you init this up, and again, this is a root level component. When you init this up, you're just calling confirmation service dot the name of the observable dot subscribe. And now, this basically is just saying, just passing that up. And that's actually popping up the dialog, and then you have your accept and reject functions as well. So this is a very powerful concept of the service knows nothing about the components, but the components depend on the service to do its work. So now I can inject this confirmation service anywhere in the application and just with one line of code say .confirm, and we know that we have a dialog out there that's responding to the events that are fired. Okay, so we've talked about the component. Example number 2, and this is what you'll do. Every application that needs data, you need to do an HTTP call, right? So we have this concept, and it might actually be easier just to go through in here. We have a profile data service. In general, you never want to do direct HTTP calls in your components. And the main reason for that is we want to be able to unit test stuff. We want to be able to mock and return fake data. We don't want to have to have that dependency on that network in order to do it. So we have a profile data service that wraps this HTTP service. And even the HTTP service, you'll notice that this is not an Angular HTTP thing. This is actually a service that wraps Angular service calls. So, and all we're doing from all of these methods here is we're just returning observables. So we just call HTTP service.get, or whatever we're doing here, and just returning an observable that we can subscribe to. So this is the actual HTTP service. And I like to get in the habit of wrapping any third-party thing, or even sometimes the Angular stuff. I like to have my own kind of API that I wrap around it in order to do what I want it to do. And a good example of that is, for example, for a GET request, I want to be able to just pass an object that will automatically be parameterized in that query string when I do my GET. So, you know, I have a private method that goes and builds out those parameters, so I don't have to even think about it. And again, we have this strongly typing that we do with the observable. We return the data from that. And then, in order to subscribe to it, you just do your data service dot whatever the method is that returns the observable, and just do dot subscribe on that. And this effectively, in the context of HTTP, this is just your standard. It's almost like a promise object. It's a one-time thing. And as a result, you don't need to unsubscribe from that because your HTTP stuff, it automatically unsubscribes for you. Any other observables, it's a good idea to unsubscribe from them when you're done to clean up those resources. Now, this, you can go nuts with observables. This is a more advanced example. Now, RxJS is the library that it uses behind this, that Angular uses behind the scenes. And one of the kind of frustrating upgrade points is when, as soon as they went to version 5.5, we used to have this Fluent API syntax that you see on line 7 here. They, you know, dot map, dot filter. Again, these are the operations that you can perform on these observables. Well, then they changed it to just do a basically, we want to be able to apply operators to this stuff. So now we do the .pipe, and inside the .pipe, we have these comma-separated lists of our functions that we can call. And all this is open source. You can see how all these are working. But just to kind of give you an idea, this is basically just the search box on the site that we do. We have the ability, like, for example, we have a debounce time operator that doesn't call anything. You have that 300 millisecond delay in order, like if you're typing in a search term, you don't want it to immediately hit the server. You want to give them some time to type. So you have that delay there. Only fire if it's a new value. And then you have this tap operator. If you want to do some form of logging, or you want a side effect to happen inside that tap, you can do that, and it will return a copy of that observable. You have a switch map operator, which flattens the data into one observable. And then your standard map, which means I want to do a data transformation of the data I'm getting back. I want to transform it into an object that my component can consume a little easier, and because a lot of the APIs are more general purpose and things like that. You always save your catch error, anything that goes wrong, your error handler. So again, this is just an illustration of just how powerful observables are compared to promises, and how this rich feature set that you have available to you. Let's talk about forms. I don't think any one of you guys are wanting to go home with this weather. Just stay in here the whole rest of the day. So we have two approaches to building forms in Angular. We have template-based forms and reactive-based forms, or they're sometimes called model-based forms. Now, reactive forms, for me, I usually like that. I think it's the better option. We have a lot more flexibility. And the main reason for that is with reactive forms, you have a lot more, all of your stuff is basically going on in the code. So you're controlling more of the behavior in the code. Whereas with template-based, you're doing a lot more in the HTML. And when you have some complex validation requirements and things like that, it's usually a good idea to go down the reactive form route. Does anyone have an opinion one way or the other on whether they prefer template-based or reactive-based forms? I don't think I've done template-based for a long time now. It's just reactive seems the better way to go. And one thing on point 3 here, I like to wrap all of my form controls so we have a consistent look and feel, and this becomes really important with third-party libraries. Third-party libraries are a dime a dozen, whether you're using Material or Bootstrap or PrimeNG, whatever component library you choose. It's nice to have your own wrapper around that so that if it ever changes, you don't have to go and make other changes in a bunch of places throughout your code. You have a single place to do that. So really quickly, I want to demonstrate this form here. So we're just editing a group. So it's a very simple form. We just have a text box and text area. And in order to, let's go back here. So you notice in my HTML, I don't have an input tag. I don't have a button. I have my own wrappers around those components. And then in the save group component itself, basically, we just have this concept of a form group, and then a form group is a collection of form controls. And the form group, think of it as both form group and form controls are built into Angular. These are native to Angular. So what I like to do, and you can do this anyway, there's a lot of different ways to wire up these forms, but I like to new up my form controls, and then this first, when you new up your form control, your first value becomes whatever data you want to bind it to, or whatever state. Whether you want to have it disabled, whether you want to populate it with an initial value. And then you have this array of validation rules. We'll talk about that briefly in a moment here. And then I new up my form group here on line 90, and I just go ahead and set all of the controls to whatever I newed up above. So that's one way to do it. There's lots of different ways. We'll talk about this form validation service as well shortly. So let's look at one of these. So the Cubs text box that you saw, that's where now you're starting to see the raw underlying native HTML elements, like the inputs and things like that. And this is where you would see, if you had a third-party library, you would see your custom tags here from whatever library you're using. I like to throw in my validation error messages. I like to encapsulate that all into the component. If you'll notice here, the actual Textbox component that we have, it actually implements, or it extends from a base class. So we do have a parent class. And the reason for that, I usually don't do a lot of inheritance with my components, but I like to have base classes to share some functionality that's common to all inputs or form controls. The thing with inheritance, you just do the extends keyword, and then inside your constructor you call super. That is required whether or not you have a base class constructor or not. You call the super method, that will call the base class constructor, and then you have access to all the properties of the parent. And so this is the base class that it inherits from. So validation. Validation is very testable. It's very self-contained in Angular. I really like it. We basically just have one function that we're implementing. We have this ValidatorFN interface that we implement. So here's a simple example. Now, Angular does have some built-in validation, but I still like to wrap every validation rule with my own in order to have a standard interface, a standard API, if you will, with people that are consuming these validation rules. So for example, so all you do is, you notice here, it's implementing this interface, which is basically just one method that returns, if there is a failure in the validation, you return an object with properties, whatever properties you want. And then if there's a success, you just don't return anything. And this is so you can daisy chain these validation rules together, and you can have pass-throughs as you go through. And if there's any objects after you run through all of those different validation rules, if there are no objects, then you know that everything passed validation. So it's the static validate function here that you're implementing. Now it's a little confusing. It's sometimes hard to read until you kind of wrap your head around, because everything is a static class. This is a very stateless, validation is very stateless, and mainly so we can do unit testing and things like that. We can also pass additional parameters into that validate function. So for example, this max length rule that we have here, and then we can pass other things into that error object if validation fails. Now, why would we want to return success if there's no value to the form control? And the reason for that is, again, we want to daisy chain these together. If we say, here's the max length, we also want to allow nulls, because maybe we don't want that field to be required. So in general, it's nice to get in the habit of saying, I have to, when I'm looking at my validation rules, think of this in combination of other validation rules and how those are going to stack up against each other. So we don't want to do two things in the validation rule. We don't want to require the field and restrict the length, if that makes sense. So in other words, the validation rules, with the exception of the required validation rule, should apply only if there's a value present. So we have, you noticed up here in my component here, I have this custom component here, this child component, HTTP validation error messages. I wanted to take a look. It's nice to have a standard place for all your error messages. I like to do it this way. Again, this is just one way to do it. And basically, you could just say, so that when something isn't valid, it'll just go and find the errors and automatically display them. And that way, when you go to add your validation rules to your form controls, you don't have to worry about those validation error messages and having to repeat yourself a lot in your templates and things like that. So really quick, I wanted to show so that message that you saw, again, we passed that in to the component and it handles it automatically. Now, when I hit save, if there's still validation errors, I want a kind of a validation summary that summarizes all those errors before it's allowed to submit. And that's handled through a service. So again, this is one way to do it. There's lots of different ways to do validation. But I like to have this form is valid check, and you pass in the form group, and it basically just calls the valid. These are properties that are built into these form groups and form controls. You have different states on the form group, and then each of the form controls have their own state as well. And I just say, hey, I have my notification service. If that's not valid, go ahead and show those error messages. Otherwise, return true. So it's just a Boolean. And then this is kind of this helper method that loops through all of those form controls and sees if there are any error messages there. So basically, that's all we're doing. We just have our form controls that we're doing up. These, again, these are static classes that we're just calling the validate method on, passing in our parameters. And then when we go to save it, with basically one line of code, we just call that validation service to see if it's valid, and then we go ahead and do our save. So any questions so far on forms, building reactive forms in Angular, components, communication? Okay, let's talk about interceptors. Interceptors are very powerful. This is a feature that is global in nature. If you're familiar on the back end with in the olden days, we had HTTP modules, HTTP handlers that would run on every request. You have this HTTP request pipeline, and at any phase in that pipeline, we want to alter the request and send it on to the next handler. We have the concept of middleware in .NET Core. So this is the same concept, only all of this is happening on the client. So basically what an interceptor is saying is, here's my HTTP request or response, whichever way you're going, and we're saying, I want to alter that request before it hits the wire and goes off to the server. And this is a very powerful thing that you could do. So we register, remember how I said that providers array is most of the time pretty empty because now we no longer have to register our services? Well, when it comes to HTTP interceptors, we do register them in the providers array. Now, one thing you have to remember is that order matters. So when you have your pipeline, you want to make sure that those interceptors are firing in the specific order, because if you, so in other words, for example, auth header service, I probably shouldn't name these interceptor, but this class, this interceptor class, will receive whatever this guy mutated. In other words, it's mutated. So if this guy alters the request in any way, this guy receives the modified request, not a brand new copy. And this is by design so that we can alter as the HTTP pipeline's going through, we can alter it at several different levels. And then this multi here means that we have multiple interceptors. So when would we want to use them? There are 4 examples that I can think of that are very common. One of them is that root URL. We want to be able to just say, /API/ whatever. Whenever we're doing all of our API calls or whatever, we want to be able to say, depending on the environment, I want to be able to prepend that base URL, the server, the domain, whatever you want to call it. And then, so this is a very simple example. All we have to do is implement that HTTP interceptor class. And again, a lot of these interfaces is just one method that you have to implement, and it's the intercept method. Takes the request, and then you can pass it off. So, and notice that it returns an observable, so you can subscribe to that. So I just have my environment variables, which are think of that as like your web config on the client, or config settings that are specific to your application on the client side. And then all we're doing is prepending that base URL from my config file to the request URL. And you just call this request.clone that says take the request as is, but then alter this one property. Okay? And then we just hand it off to the next interceptor, or if we're done, then we're done, and it goes out to the network. Now, there are several ways to prepend a root URL. You can use a proxy, you can do lots of other things, but I found this is really nice. Another example of an interceptor is authorization. So you need to, any request that needs to be authorized, which for most APIs is very common, you have to have, if you're doing token-based authentication, you have to have a authorization header value. So that's a great use case for an interceptor. So we say we have my auth service that, hey, if they're logged in, go and grab the access token from the service. And again, we have access to basically any part of the request you want to alter. In this case, we want to add a header. So every request that goes out has that bearer token in the header. And then we clone it and send it off. Another one is a global loading indicator, and by extension also a global error handler. So in this case, normally, there's lots of different ways to do loading indicators, and sometimes it gets really messy, especially when you're doing a lot of asynchronous calls at the same time in parallel. And the way I designed this site is we just have a single loading indicator that can handle multiple network requests at the same time, just prepends the messages to the loading indicator. I can show you an example of how this works. So if I go to any one of these, this is a route guard. I'll show you that in a minute. So I don't know if you noticed it, but you saw that loading indicator actually had a couple of different API calls that it was doing at the same time, and it showed on that message those different calls. So what's nice is I want to be able to not have to think about it. Whenever I do an API call at site-wide, I just want to pop up a loading indicator. The nature of our application here is we want to block the UI, which means we don't want the user going around and clicking stuff while stuff is loading. It could cause the app to be in a weird state. So we can handle that globally. Basically, we just say, we have some exceptions, obviously. If we have some background processes that are doing something we don't want to show the loading indicator for, we still want them to be able to do stuff while other processes are firing off. But otherwise, we just have the loading message, and we just call notification service.loading. And that is similar to the confirmation service. It's just basically it has an observable and is broadcasting that something is happening, and then that loading component subscribes to that and pops up the loading indicator. What's nice about this is, so we do the next.handle, and again, remember all of these are observables. So we're doing the .pipe, and now if the request errors out, this will catch both your client-side and your server-side errors. We can catch that. And so instead of having the loading indicator hang if an API call fails, we can come back with an error message and stop and show that error message to the user. Otherwise, we have the finalize here, and we could just say the loading's done once the request comes back. So again, this is handling the coming back. Now what's nice about observables, again, remember you can cancel. So if a request is canceled, and the prime example of this is if you're doing like an autocomplete on a search box, you're constantly sending data to that API. Well, sometimes if you're typing and you're doing like 4 or 5 different API calls, you want to cancel all those other ones because we don't want to send the results back for every single combination that they type. We just want to show the last thing that they typed. So if the request is canceled, we can also stop the loading indicator as well. So this kind of is a two-purpose interceptor in that it's handling that loading indicator and it's also a global error handler at the same time. Fourth example is the caching service. So this was actually not my idea, but I got it from a Pluralsight video. Talked about a way to have global caching. So they always say in the industry, the fastest request is the one never made. And the reason they say that is because of caching and the advantages we get. So if I have my network request here, let's reload the page here. Actually, let's start over here. Let's see. So here's my network activity here. As I'm clicking from place to place, you'll notice we're doing 2 requests, and really this is just an options header. It's not an actual, it's not a duplicate. And then this is the actual GET request. As I'm going back and forth, you're seeing these are obviously making those API calls to get the data. Well, now when I go back, you notice it's instant, except for the images. But as I'm going back and forth, it is caching that data, so now I don't have to worry about other network requests. So the way that is handled is through an interceptor. So we have a caching service that says we can look at the actual method type, and we say if it's not a GET, so if we're doing a post or a put or delete or something, obviously that we want to clear out the cache in those cases because the data is stale at that point. Otherwise, we can go ahead and call the caching service here on line 15. And let me hurry and show that, how it's implemented. It's a very simple service. this one. Now, this is maybe not typically what you'd want to do in an enterprise application or an application where lots of different users are editing data and you want to always have a fresh copy of that data. And this is a little bit hokey and hard-coded, but for now you get the concept of I'm caching up to 50 items, and then after that we'll go ahead and flush it out and decide at that point that we can get fresh copies. So this is just kind of an arbitrary, not the best code in the world, but it's basically just saying we don't want this cache to get too large because all this is being stored on the client. The entire HTTP response is being stored on the client for the cache. And this is the whole service. You know, it's basically 30 lines of code, and you're just saying, you just have an object. Again, services are singletons, right? So this .request, you know, this is, you can grab this. This will survive route to route to route. You have this object that basically is a key value pair of all of your responses. Okay. Any questions about HTTP interceptors? Okay, let's talk about route guards, or route resolvers are kind of in the same category. So we have kind of this similar to the HTTP pipeline with interceptors and stuff like that. There's also this kind of pipeline of guard, they call it guard processing. And so when you go to access a route, so if I go to, you know, /profile, /groups, whatever my route is, there's a life cycle or a bunch of events that fire that you can tap into. And it can go both coming into a route or leaving a route. And the idea is, route guards are a simple true-false interface. So the method that we implement just returns true or false, and that is saying whether or not we actually will load the route. So the two most common use cases for route guards are, obviously you can think of authorization. If we have someone that we don't want to allow them to get to a route, we put up a route guard. But there's also another application of a route guard that I really like, is if the component is in an invalid state. For example, they have a form and they haven't saved changes yet, or whatever the case is, that we don't want to let them leave the route. So the authorization is coming in, the unsaved changes is going out. We can implement those using route guards. So the authorization one, this is, all we do is implement this can activate, and this would be the route guard here. We can inject our services just like we do with any other class. And this can activate method basically has two parameters, next and state. And the state is the current state of the router. So you can have, okay, what's the URL? And this is not the best way because we're string parsing here, but the idea is, okay, we have the current. So this route would fire if we were trying to So this is before we load the /profiles route. We go and get the profile, and we look, and you notice the return type of this guy is an observable, or promise, or just a Boolean. So we can go and do API calls if we want to do a server check or whatever. We can do that delayed processing in determining whether or not we load this route or not on the route guard. So we're going out, we're getting the data, we do the subscribe because again it's asynchronous, it's an observable. We have the results, and now we can call the role service, which is basically just, here are the roles, can they do this type of thing. This is one-to-one with the server-side roles. We're going to talk a lot more about role-based and policy-based authorization in the next brown bag when we hit the server. But basically this just mirrors kind of those, implements this kind of stuff on the client. And then we basically just say simply, what's nice about this is we can say, if they're not allowed, we can actually do something. We can send the user a message or notify them in some way for a better UX rather than just not loading the route, because they would click it and nothing would happen. So what's nice about this is you can do whatever you want inside this method. I mean, granted, this is a side effect, but sometimes that's desired for sake of UX. And then you just return the resolver of whether or not they're allowed. So this is a very fairly straightforward way of a route guard when it comes to authorization. The other one, and this is the one I wanted to demo, is that unsafe form. So if I go let's just say I'm in a group and I want to edit this guy. And I change something, and then I leave the route. We have this pop-up that says, hey, you haven't saved changes yet. Do you want to leave without saving? Okay? If they click no, the route doesn't load. So that's a very simple thing to implement. Same kind of concept, only instead of can activate, we implement can deactivate. In other words, you're leaving the route. And what's nice is you can pass in, you can make this generic and pass in, you know, a component or whatever, so you can have access to that component's methods and properties. And the can deactivate is the same kind of concept. It returns either a Boolean or promise or observable. I chose to do this as a promise just because it's a very simple yes or no scenario. So we wait until the user tells us whether or not they want to leave the route. And if we do, we just resolve it with that value that they've chosen. And we're using that confirmation service that I showed you earlier. So in order to register your route guards, your route resolvers, it's very simple. In your route file, as you're declaring, you know, as we showed earlier with the routing, you have your path, which maps to a component. You just add a couple of other properties, can activate, can deactivate, and that's just the name of your class. You're going to have multiple route guards on your activate or deactivate. But very, very simple way to register your route guards and your resolvers. Resolver, I don't want to get into too much detail on this. The basic idea of a resolver is that I want some data to be there before I even load the route. And so we can achieve that with resolvers. Just know that it's out there. I prefer showing as much as possible up front and then just having like a loading indicator or something else. Some people would prefer, or maybe for security reasons, you want some data to be present before you start loading the route. So that's an easy application as well. Any questions on route guards or route resolvers? Okay, we have just a few minutes left. We're almost done. Wanted to briefly talk about authentication, and this will be client-side authentication, which is kind of smoke and mirrors. It's important to distinguish between authentication and authorization. You know, authentication is basically saying, who are you? We're just identifying the user. You know, you're showing someone your ID, versus authorization, which is say, okay, we know who you are, now what can you do? What are your roles? What are your permissions? Things like that. And one thing to remember, this I really enjoy Kevin Dockex, I think his name is. He does some great Pluralsight courses on security, and he mentioned this. He said, the thing with security is a lot of approaches will work, but most of them are not a good idea. My advice with security, don't try to do it yourself. There are a lot of points of failure if you try to do a custom solution. When possible, by all means, try to use what's there. So we have OAuth 2, and we have OpenID Connect, which kind of extends some of the OAuth 2 stuff to handle authentication authorization. We have these different flows, and in a recent .NET Rocks podcast, they actually had some of the architects of the, I think it was Identity Server. He talked about how these flows are kind of changing and being simplified to specifically address SPA applications. SPA applications is the wild, wild west when it comes to security. Because if you remember, with SPA, it's everything's there. You know, these route guards and these authorization, all that stuff, it's not that hard to step through code, change a few values, and really kind of change things up. So you want to be really careful in how you're securing on the client side, realizing that the ultimate security is on the server. With your role-based restrictions, your authorization, all that, the client is more for a better user experience, better UX. The server is where a lot of that security really actually happens. And for purposes of a SPA application, in other words, where the client is the browser and you just have an endpoint, when we're doing token-based authentication, we'll talk about this more next time as we talk about Identity Server and how to implement authentication. Implicit flow, whenever you see the different articles on different kinds of flows, we definitely will go with the implicit flow because we have an authorization endpoint, but our client is very public. This is not a desktop app on an intranet thing. This is not necessarily a mobile device. But in this case, in the case of web development, it is very much a public client. And so that way, we cannot secure the client. So what we do is we have what we call short-lived access tokens that we do. And we'll talk all about that next time. But just wanted to give you a brief introduction. Authorization code, when you have server-to-server communication for that, you can have longer-lived access tokens because you know that the endpoint is secure. And then you can do a mix of the two with hybrid. So basically, just briefly, because I know we're almost out of time, the auth service that we have, if you guys are familiar with token-based authentication and OIDC, there is a wonderful client-side library called OIDC Client. We see we've imported it. It's just an NPM package. We have it on line 4 here. That handles most of the heavy lifting of doing the redirects and handling the token, storing of the token, all of this kind of stuff. We'll talk more in detail next time, but the basic idea is you have this settings object. You say, okay, who's the issuer of my token, the authority? What's my client ID? What are my redirects URI when it comes back? All of that kind of stuff. Where do we store the token after we've authenticated? We'll talk about some of the controversy in storing in local storage and why that's not necessarily a good idea for security reasons. But for our purposes, we'll go ahead and store it in local storage. This is not an app that needs to be super duper secure. So we have this user manager. Again, these are all methods from the OIDC client. So your login, your logout, you notice these methods are very, very thin because all we're basically doing is calling that OIDC client. These are just wrappers around the OIDC client class. In terms of role-based authentication, again, we'll talk about this more because this is a server-side thing. This is basically mirroring the server side. Now we can say, do we want to lock down with our route guards or whatever? We want to check those permissions and make sure the user's authorized for things. We have a service for that as well. So really quick, let's see, almost out of time here, but I wanted to show how this flow works. Let's see. So we click login, and you notice now we're doing OAuth. We're just using the Google as an OAuth 2 provider. We've completely left our site. We are no longer in the STD profile site. We've gone out to Google, and we're authenticating with them. So they're going to be the ones that are going to provide us with that token. So we log in, and then it sends us back to the site. Now we have on the server side we're authenticated. And if you look at the endpoint here, this guy here, similar to like we were talking about earlier with the HTTP interceptor that we have, our authorization header is automatically being sent up on every request. So again, the details and the flow and everything else we'll talk about next week, but just it's a very simple, straightforward process. If we're going out to an external site, we're saying, Google, you handle all the authentication, send us back a token, and that token will be short-lived, again, because we're on the client, but we also want to handle silent renews and things like that. We'll talk more in detail about all of that next time. But the basic idea is that as long as they're hitting the API regularly, making API calls, we want to make sure that we're renewing that token so that they don't have to constantly log in, you know, every 5 or 10 minutes. Okay. We didn't have a lot of time to cover Web API design. Just in the couple minutes we have, there are different levels. They call it the Richardson maturity model of Web API design. And back in the olden days, if you remember WCF and we had XML and WSDLs and all that fun stuff, they call it the POX swamp, and it was a very configuration heavy, a bit clunky sometimes, very verbose. We had a lot of issues there. So we kind of went up to this, okay, well, let's do RESTful Web API design. So we have level 1 here, and the idea here is we have a URI endpoint that represents a resource, but there's a single verb on that resource. Level 2, and this is kind of more of the standard REST, is we have a single endpoint, but then we operate on that same endpoint with different verbs. So we do, you know, /profiles. We can do a get to get the list of profiles. We do a post to create a new profile to that same endpoint, just a different HTTP verb. And then put and delete don't really make sense in the context of that /profiles, but if we had a specific profile like /profiles /ID, then we could do a put and a delete against that endpoint. And then we have level 3. This is the concept of, I think it's HATOIS, I don't even know how, it's a terrible acronym, but it basically stands for Hypertext as the Engine of Application State. And that is a fancy term for, we want our API to be self-documenting, to be discoverable, and for people to be able to easily navigate around. So let me illustrate kind of the base concept of that. If you go to, let's see. Actually, I think I'm in my local here. You know what? We're about out of time, so we will pick this up next time. We'll talk about designing a RESTful web API. We'll talk about the different HTTP verbs and status codes, what to return from your API, and then we'll actually start. We'll finally get to the server. I promise we'll get to the server side of the stack. We'll talk about .NET Core. We'll give a brief introduction to that. We're also going to talk, I want to go a little bit into back-end architecture. So we have this concept of separation of concerns and domain-centric design and things like that, where we're not whatever we're constructing our database objects or whatever with our object relational mappers, we don't want to send that data straight as is to the client. That most people can agree on. And then on the server side, we have this concept of a view model. It's specific to the client. But then there's this in-between, this kind of this gray area. We call it the domain, domain model, whatever. We're going to talk about how to separate those layers and how to properly pass data through the different layers, from the client app all the way down to the domain layer for the business logic, all the way down to the database. So we're going to go end-to-end. Once the data hits the server, we'll talk about that. And if we have any time, obviously I want to talk about authentication authorization on the server. We'll get into that pretty heavily. And then if we have any time left next time, we will talk about the deploying. So your Azure, we're going to provision we're going to set up a full CI/CD pipeline and talk about how this site was deployed to Azure, kind of eliminating the need for your DBAs, your sysadmins, let Azure kind of handle all that for you. So we're going to get pretty heavy on the back end. We're going to start out with the web API design and move up and talk about these other topics as well. So next month will be part 3 of 3, and we'll go from there. All right, thanks everyone.